In this video, I'm going to show you how to use graphical analysis to learn a little bit about a data set that you recorded with one of the vernier probes. So here I have two lines from two different temperature probes. This group was looking at different angles, and so if I click on the y-axis, you can see that the blue-green line is 30-degree angle and the purple line is 75-degree angle. So just eyeballing it, I can see that the purple line, the 70-degree, did get hotter, and it got hotter faster, but I want to quantify that, all right? I want to apply some numbers to that. So I'm going to show you a couple tools you can use to do that. Say the first thing I wanted to write down in my data table was the initial and final temperatures of these two trials. To get that off of my graphs, all I need to do is click on any point on my graph, and I can kind of move this line around and see at a given time what the temperatures were. So I'm going to slide this all the way over to 0, and I can see that my purple line, 70 degree, had a 25.0 degrees Celsius initial temperature, and the blue line had a 24.9 degree initial temperature. Okay, and so I could write those down. If I'm curious what happened after the full 5 minutes here, I can go over to time equals 300 seconds and see that the purple line was 28.1 and the blue line was 26.8. I can also look at any time in between if I'm curious. That's a really easy tool to use. And so that's how you would get a exact data points at the beginning and end of the trial. One thing that might be interesting here is to look at the rate of change of this temperature. And so I have some tools here in graphical analysis that can help me look at that rate of change. So what I'm going to do here is highlight all of my data. Make sure the whole thing is highlighted here. And I can slide these sliders at the bottom around to make sure I'm going from 0 all the way to 300. And then I'm going to click on Graph Options in the bottom left corner. Click Apply Curve Fit. You can see a couple lines pop up. For science class, we typically just deal with linear fits. And so I'm going to click Apply here. And I have a little data window that pops up that gives me an M, a B, an R, and an RMSE for the blue line and the red line. You probably know from math class what M and B stand for. M is the slope of this line. So the slope of the blue line is 0.0047 degrees Celsius per second. That tells me how many degrees Celsius the temperature went up each second. And so that's the rate of change for the blue line. And for the purple line, we can see it's 0.0078 degrees Celsius per second. The rate of change for the purple line is a lot higher than the blue line. B here is my y-intercept, right? Ideally, if the rate of change were constant, that should be the same as my initial temperature. But if we look over here at the y-intercept for these lines, it is definitely not the same as the initial temperature. That means that this linear fit is not really a great fit for this line. So we'll think about some ways to deal with that in a second. The R and the RMSE, these are two ways that we can ask how well the data fits the line. And so I'll leave it to you all to explore that. There's a reading in the Designing Controlled Experiments document that tells you a little bit more about R and RMSE, the correlation coefficient, and the root mean square error. These numbers are pretty good, but I'm going to show you how to improve those a little bit. So that's just the basic way to get the slope and the intercept for this data. But like we said, this is not a great fit. It doesn't really match up with my data. I'm going to close this out. I'm going to just look at my data carefully. And I'm going to notice that there's a little bit of an increase right here at the beginning that is different from how the temperature increases for the rest of the time. So maybe I'm going to ask myself, okay, once something weird, once this initial stuff happens, what happens long term? So maybe I just want to start from, I don't know, 50 seconds where things start to level out a little bit. And again, go to graph options, apply curve fit. And now look at my purple and blue lines now. They match up with the data a lot better. And so this slope, 0.0039 and 0.0065, may be more accurate of a representation of my data than the original ones when I was using the whole data set. So I might record those values and say in my notes from 50 to 300 seconds, the slope was so much. If I'm curious about what's going on at the beginning too, I could even do another one where I select, maybe the first 20 seconds or the first 15 seconds where the data looks pretty linear, and even do another curve fit. And I might be able to compare this. So at the beginning, for the first 3 seconds, the slope was this. At the end, the slope evened out at this. So you can see I can do some pretty powerful analysis very quickly to look at the rate of change of my temperature data. So that's, I think, it for now. If you are using these rate of changes and slopes on graphs in graphical analysis, you may want to take the version of your graph with the lines on it and then go to export and click save PNG or click copy to grab this exact graph with the lines on it. Sometimes this data label gets in the way. You might want to change the graph shape to make it a little cleaner. You can play around with those options, but this would allow you to have a copy of this exact data set in your notes, which can sometimes be useful.